Good morning. Today we are going to be going over solid figures and using nets to find the surface area of prisms. So we did a little bit of this already. Before state assessments, we went over surface area a little bit, and so we're just kind of reinforcing it today and learning a few new things. So today we will learn how to represent solid figures using nets and how to find the surface area of prisms. So 3 vocabulary words that we're going to focus on today are face, edge, and vertex. So a face is a flat surface of a polyhedron, and a polyhedron is just going to be a 3D shape today. So a face is the flat surface. So this is the face, that's one face, this is another face, this is a face, the bottom is a face. So this rectangular prism right here has 6 faces altogether. So face is the flat surface. An edge is a line segment where 2 faces intersect. So this is the edge. This is also an edge. This is an edge. This is an edge. All of these are edges. Okay, so that's what edges are. And the last one is a vertex, which is a point where 3 or more edges intersect. So, this is a vertex, this is a vertex, vertex, vertex. Those are all vertexes. Some of you might maybe know those as points. Either one would be correct, okay? But the more technical term is a vertex, and it is a point where they intersect. So those are the 3 vocab words we're going to be discussing. So on these examples, we are going to find the number of faces, edges, and vertices. Okay? So looking at this, we have, let's see, it's a rectangular prism. So we have one face on the bottom, one face over on the right, one face on the left. We have the top, and then we have the back and the front. So the back is up there, top or front is there. So this has 6 faces. Okay, think of it as any, like a cube or a die. Think of it as your cereal box. It has 6 faces. And then edges, so we have 1, 2, 3, 4. And we also have 1, 2, 3, 4. So that's 8 altogether. But then we have the edges that connect the bases. So that's 4 more. So that means we have 12 edges. And then the last thing we're going to look at is vertices. So remember, those are the points. So that's 1, 2, 3, 4, 5, 6, 7, 8. So this means that has 8 vertices. So it has 6 faces, 12 edges, and 8 vertices. On this one, okay, one thing that I always look at when it's a pyramid especially is the base first. So the base is right down there, and it's in the shape of a triangle. So that means it should have 3 faces coming up to a point. So it has this right side, it has this left side, and then it also has the back. So that means it has 1 base and then 3 faces coming out of the base. And so that's 4 faces. For edges, I still usually start with the base. So that's 1, 2, 3. And then the lines that are coming up to a point are also the edges. So that's 4, 5, 6. So it has 6 edges. This triangular pyramid does. And then the last thing are the vertices. First thing, the point at the top is always a vertice. So that's 1, 2, 3, and 4. So 4 vertices. So 4 faces, 6 edges, and 4 vertices. On this one, okay, so I can see right away for faces, I have a triangle here and a triangle here. So that's 2. And then I have the right side, the left side, and we have the bottom. So that would be 5 faces. For edges, remember, so I'll start with this base. So 1, 2, 3, and then in the back, 4, 5, 6. So there's 6 just for the bases. And then remember, there's the lines that connect the two bases. So that's 7, 8, 9. So there's 9 edges on this one. And then vertices, start at this base. We have 1, 2, 3, 4, 5, 6. So there's 6 vertices for that one. This one, I want you to try on your own. So pause the video real quick, figure out faces, edges, and vertices, and then play the video to see if you got it right. So faces, we have the bottom, which is 1. And then we should notice it's a square, so that means we have 4 faces on the outsides coming up to the point. So there's this right side, that's 1, the back side, 2, left side, 3, and then the front is 4. And so with the bottom, that would be 5 faces. 1 on the bottom, 4 around it. The edges, so start at the bottom base, that's 1, 2, 3, 4. And then the lines coming up would be 5, 6, 7, and 8. So there's 8 edges. And then vertices, remember the one on the top is 1, and then 2, 3, 4, 5. So 5 faces, 8 edges, and 5 vertices. So we've got our vocabulary words down for face, edge, and vertex. Now we're going to talk about the difference between some prisms and pyramids. So a prism is a polyhedron that has 2 parallel identical bases, and the lateral faces are parallelograms. So they have 2 bases. That's an important distinction. Okay? So for this one, we know this base and this base. So it's a prism, and if the bases are triangles, then it's a triangular prism. If the bases are rectangle, then it's a rectangular prism. Okay, so it's all about what the bases are. But they have 2 identical bases. And then pyramids, a pyramid is a polyhedron that has 1 base, and the lateral faces are triangles. So you can see it has 1 base on the bottom, and then the triangles go out to make the point at the top. So we have prisms, pyramids. One easy distinction between them is that the pyramid always comes to the point, at the top right there. Okay, that's it. If it comes to a point like that, that's a pyramid. Prisms do not do that. Okay? So the shape of the base tells the name of the prism or the pyramid. So since the shape of this one, the base was a triangle, it's a triangular prism. Because the base of this one was a rectangle, it's a rectangular pyramid. So we're going to name a few of these. So right away, I can see that it comes to a point, so that makes it a pyramid. And I just need to figure out what type of pyramid. Is it a rectangular pyramid, hexagonal pyramid, triangular pyramid? What kind of pyramid is it? Well, I have to look at the base, so I can see the shape of the base is a triangle, so it's going to be a triangular pyramid. Okay, so that's a triangular pyramid. On this next one, it does not come to a point. So that means it has to be a prism, and I have to find the identical bases that are opposite of each other. So that would be this one and this one. That's what makes it a prism, because it has 2 bases. And then I have to say, okay, what shape is the base? And I can see that it's a triangle, so this would also be a triangular, but this one is a prism instead of a pyramid. So I want you to take a look at those. Okay, so we have a triangular pyramid on the left, a triangular prism on the right, and notice some of the differences about the two. This one, it does not come to a point, and I can tell it has 2 identical bases. So that is a prism. And you have to ask yourself, what shape is the bases? And those are triangles. So this one is also a triangular prism. So this is the exact same as the one on the left. One is just, they're facing different directions. One is sitting on the bases, the other one is not. So on this one, try it on your own. Try and come up with whether it's a pyramid or a prism, and then whether it is triangular, square, hexagonal, any of those. The main ones you're going to be focusing on are triangular and square and rectangular. Okay. So this point up here means it's a pyramid. And then its base is down here, and that is probably a square, but we're not sure because it doesn't say. So we're going to say rectangular prism. But if you said square pyramid, I would also count that correct as well. Okay. So that's how you decipher whether it's pyramid or prism, and whether it's triangular or rectangular or square. Okay. So go ahead and flip your pages over. And we're going to do the same thing on this one, but it is nets. So remember, nets is the shapes unfolded. So we have to figure out what shapes they are. Okay, just like we did above. So on this one, we can see everything is rectangular. So we know it's going to be a rectangular because that's all it is. And if you folded those up, it would not be a pyramid. Okay, remember, pyramids have to have triangles in them, so this has to be a prism. So this is what like your cereal box would look like if you unfolded it. It would be a rectangular prism. And then this one, so we can see this would be the base, and it's a triangle, so that means triangular. And then if you folded those up, the other three faces, they would come to a point. So that would mean it's a triangular pyramid. On this one, the base is a square. So we're going to say square. And then is it a prism or is it a pyramid? Okay. Well, all four of these, if they folded up, they're all the same. They would fold into a pyramid. So that would be square, pyramid. And then the last one, remember it has to have, a prism has two identical bases that are opposite of each other. So that would be these two. So it is a prism because if you folded this up, it would not come to a point or a vertex. And then the bases are triangles. So it would be a triangular prism. Okay, so if you unfolded this right here, it would look exactly like this. Okay, those are the same shape. One is just folded and one of them is unfolded. So now we're going to go into actually solving some problems. So surface area is the sum of the areas of all of its faces. So remember, sum means add. So we got to find the area of all 6 faces, or however many there are, and then add them together. So on this first example, remember, if you have a rectangular prism like this, we have the front and the back. So that's going to be F/B. And then we also have side/side. And then we have top/bottom. Those are the 3 we're going to find. So let's start with the front and back. So the front right here is this, or you can use the back. They are the same thing, so that's why we put them together. So if we look at this back right here, the base is 4, height is 3. So that's going to be 4 times 3. Remember, you can use a calculator. So 4 times 3 is 12. And because there's 2 of them, this front up here is the exact same. We have to multiply by 2. So we would get 24. So the surface area of the front and the back is 24. And now we do the same thing for the other 4 sides, or faces. So now we have this side and this side. And to find the area of that side, it's going to be 3 times 2. So we write 3 times 2. Well, 3 times 2 is 6. Because the left side is the exact same as the right side, we got to multiply by 2. So 6 times 2 equals 12. And then our last ones are top and bottom. So that's this one and this one. So if I'm looking at the top, I'm going to be using 4 and 3 to find the area. So 4 times 3. No, sorry. Not 4 and 3. 4 and 2, because this right there is 2. So we'd have 4 times 2, which equals 8. And the top is the exact same as the bottom. So we multiply by 2, and we get 16. And now, to get our surface area, we have to add all 3 of those together. So 24 plus 12 plus 16. You can use your calculator. And you should get 52 centimeters squared. Remember, it's surface area. Anything area, we always square. If you are feeling confident, then you can do this one on your own. Pause the video. But note that it is a cube instead of a rectangular prism, so it's different, which makes it easier, actually. So notice how all faces are the same. They all are going to be 0.5 by 0.5. Every single face is going to be that, which means since they're all the same, we just need to find the area of one face and then multiply by 6 because there's 6 faces and they're all the same. Okay? So I would just do 0.5 times 0.5 and go ahead and put that in your calculator. And you would get 0.25 or 25 hundredths. So that's the area of one face, but we need to know the area of all 6 faces. So I would do 25 hundredths times 6. And you would get 1.5, and it would be meters squared. That would be your answer. So remember, cubes are an easier one because all 6 faces are the same. So those are rectangular prisms and cubes. Now we're going to look at triangular prisms. So remember, triangular prisms, it's called triangular because the bases are triangles. So when I look at that, that's going to be this one and this one. Those are my 2 triangles. Okay. So we have, that's going to be our front and our back. And then we have side and side. So we have our left side and our right side. So I'm going to put side slash side, and I'm putting them together because they're the exact same. And then the last thing is the bottom. And it doesn't have a pair. There's not another one that is the exact same as that one. So I'm just going to put bottom on this one so I know that it's by itself. So the front and the back, those are 2 triangles. So remember, when we deal with triangles, our formula is A equals 1/2 times base times height. So you'll be wrong if you just do base times height. Triangles, you have to multiply by 1/2, which is the same as dividing by 2. So if I'm looking at the front of this triangle, I have to find my right angle. So my right angle is right here, and the 2 lines that make up that angle are this one and this one. So that means I'm going to do 1/2 times 6 times 4. Remember, you can put that whole thing in your calculator, but a lot of you can do this in your head. So 1/2 of 6 is 3, and then you would do 3 times 4, which is 12. So the area of that triangle is 12, and then there's 2 of them, so we have to multiply by 2, and we'd get 24. So then next we have our side. So I'm going to look at this one. Okay, there's a lot of numbers, so you got to make sure you're paying attention to the correct one. So my base of my rectangle is 7, and the height is 5. So I would do 7 times 5. I do not multiply this one by half because it's not a triangle. It is a rectangle, so we just do base times height. So 7 times 5 is 35. The back is the exact same, or not the back, sorry. The left side is the exact same as the right side, so I got to multiply by 2. So 35 times 2 equals 70. And then the last thing we're going to do is the bottom, which is this one right here. And so just by outlining it, I can see the two numbers that I'm going to use. It's going to be 6 and 7. It's a rectangle, so I just multiply those. And 6 times 7 equals 42. So I found the area of all 5 faces, so now I have to add them together. So 24 plus 70 plus 42. And we would get 136 feet squared. That would be our final answer. So on this last one, I would love for you to try it on your own. So pause the video now, try it on your own. This is going to tell you how you're going to do on the homework. If you get this right on your own, then you are ready for homework and ready to go. But if you get it wrong, then you can see that maybe you need to be asking the sub or Mr. Johnson for questions or asking me for help in seminar tomorrow. So first thing I notice are the 2 triangles. Those are my bases. So I'm going to have front slash back, and they're triangles. Remember, we know we're going to have to do 1/2 when we figure it out. Okay. So that's the front and the back. This right side, hopefully you can see that that is not the same as the left side. It is not the same as that left side is. Okay, so that means we're going to have right side. I'm just going to label it right. And then we are going to have the left side, which is back here. And you can label these whatever you want, whatever helps you. Okay, so that would be left. And then we have the bottom, which does not have a similar one. We would do bottom. Okay. So let's start with our triangles. Start with this right here. Okay. So we look for our right angle, which is right here, and the 2 lines that make that up are 9 and 12. So we're going to have 1/2 times 12 times 9. Remember, you can put the whole thing in your calculator, or you can do some of it in your head. So I know that 1/2 of 12 is 6, and then 6 times 9 equals 54. Okay. Are there 2 triangles that are the exact same? Yes. This one back here is the exact same, so we got to multiply it by 2. And 54 times 2 is 108. Okay, so that's my first number that I have done. Now I need to find the area of this right side. So this side or face right here. Okay. So as I outline, look for the numbers that make that up. So we have 18 and 15. So that's what we're going to be multiplying. We do not multiply by 1/2 because it's not a triangle. We just do 18 times 15 in our calculators. And you should get 270. That's our second number. I don't want to cover the number, so I'm going to erase the circle. Okay. So then the left side is this side back here. And as you're outlining, notice the numbers that you pass. So we have 18 and 9. So that's what we're going to be multiplying. 18 times 9 to get the area of that face. And 18 times 9 is 162. And then the last thing is the bottom. So we have the bottom right there. And as we trace it, look at the numbers. So 12 and 18. 12 times 18. Put that in your calculator. And you would get 216. So now I have all 5 faces, so I'm going to add them together. So 108 plus 270 plus 162 plus 216. And you should get 756 centimeters squared as your final answer. So on the homework, the first few questions are like the first page, where you're figuring out how many faces, edges, and vertices, and figuring out the names of the shapes. So those ones you do not need to show work on. But if it's asking for surface area, you need to be showing work just like we did on these 4 examples. I'm not here in seminar today, but I will be the rest of the week, starting tomorrow on Wednesday. So please let me know if you have questions.